And sorry, there's a typo here, 97. There's an Etherpad. And the minutes taker, we have Frank, right? And Sue Harris. Where's Sue? Oh, here's Sue. Okay. Yeah, okay. Thank you very, very much for taking the minutes. And Jabber room, we have anybody in the Jabber room? Yeah, okay. Blue sheet, everybody sign a blue sheet. So here's the agenda, and please look at it. And is any agenda bashing? Anybody want to say anything? If not, we'll just go forward. We have a full agenda. And so here's milestone. I just want to go through them quickly. We have some changes on the milestone and some achievement. We have our adopted working group drafts, problem statement, use cases, gap analysis, and we also have the framework and terminology, and we have our requirement draft. And we also send out the email regarding to the changes of the milestone. And in the interest of time, I don't have to go through them, but please do read through them. And if you have any objection with those changes, please reply to the mailing list. Here are the changes to the milestone. I don't have to go through them. Okay, with that, let's get to the first one. Internet slow. Oh. Okay. Yeah, you're first.
Good afternoon. This is I2NSF.
Sorry. Okay. Oh, okay.
I'm on terminology first.
You're on terminology? Oh, okay.
Am I terminology?
Yes.
Yeah,
terminology.
okay. I thought I was terminology first. Okay. Welcome. This is the terminology draft. I'm going to give you a short update. We hope we're heading toward convergence on the terminology. So we created, the motivation for this draft is that we created a reference document so that we all use the same terms. By the way, in case you're wondering, in the Asians, my words won't necessarily, will be a short summary of what's on the slides. I'm hoping you'll be able to read it, but I'm not going to read the slides. I'll just summarize what's on there for time's sake. And we're hoping that the terminology, because we've got a terminology draft, will be the same in all the drafts. So if you're writing drafts and if you're reviewing drafts, please look at the terminology and see if we got it right. We did this by looking at all the drafts we had and scanning it. So please help us by reviewing. It's an informational draft. Go ahead. We started to change things because we had some disagreement in our interim about what is the capability interface, and we've gone, that was actually very useful because it helped us change our thinking about what was our base capability model based on some of the informational model that we have, which Frank will go over. And it helped us look at our capability data model in a different way to split out the NSF facing, the stuff that's facing toward the network security function, away from the client stuff and make that stuff clearer. So we're really, when you do make comments, it really helps us all the way along. We defined the term customer and actually clarified it. And we defined the term flow and defined interface group. We think that the framework and the terminology are synchronized. We think the use case and the terminology are synchronized. So make comments. Sometime here we need to go to working group last call on the use case and the framework. So please look at this. Okay. And the purpose of this is we'll update this until we get through all the documents and then push it through. Okay. Do you want me to stay up here or go to the framework next?
Maybe it's easier you stay here for the problem.
Okay. Who's doing the framework?
Diego, but
Remotely, or is he here?
He's going to be doing this remotely.
Okay.
And that was really
Okay. Well, hopefully Diego knows that I'm going out of order. I don't see him. Is Diego in the participants list? Okay. Hi, Diego. Okay, we're going to take my other one up and then I'll sit down so we can let things go. We just want to do the use case one.
Okay.
Yes. Okay. So the problem and use case. We've been working on this for a while, but I found actually that it's been very useful. You can go to the next slide. We have a lot of really good co-authors, and they've all been actually using the pen. I'm really amazed. Like Adrian says, this working group is amazing to me because I've been a part of. Will the last person in close the door? Thank you. So thanks to the working group. Thanks for all the comments. You've been really super. Okay. We've added Rakesh and Paul as they've added more context. Now, go ahead to the next one. There are 3 parts. There's the introduction, there's the terms. Section 3 is about the problems that we're working on, and section 4 is a use case, and this is trying to help people look at it. So I took all the things from the mail list. I would love to have more comments. I'll try to be proactive in getting them in immediately after ITF or during this week. I've added use case information from Rakesh, and Paul added a section on 4.5, which described our actual I2RS hackathon case. And I won't steal the story from Paul. I will let him tell you how exciting that was. We proved that the model's actually working because we got our model split apart and implemented quickly. So I released version 4 this morning and version 3 last night. Look carefully and see if you like it. I'd like you to send comments by the end of the month, and then I'd like to go to working group last call if that would be a request the chairs would entertain. Okay, I'm done and we need to go to Diego. Unless there are questions, or any questions? Good.
You know what? I think I just use my side. It's easier.
Okay.
There you go.
So, hello. Good morning from here. I just arrived on time. The day here is not. The weather is not that good, and I promised my my youngest to bring her to school, just to spare her a little bit of rain. So that's why I've been a little bit late, but I hope it was I mean on time. So yes, this is just to update you on what we have done with the framework documents, which is now on version 4. So next one, this is as usual. This is a diagram we always show. I have changed a little bit, if you remember, changed a little bit the names of the different elements to align them with the terminology. Basically, we're talking about consumers rather than clients. Essentially, when talking about who the elements that are used in the security control to to manage the NSFs. Next one, please. And this is the next one. You will be you see how this is represented in the current version of the draft. Again, everything is a representation, an equivalent representation from the previous image, though here we have been careful just precisely to align with the terminology draft. Let's move to the next one, please. And these are the main changes in this version. That from the one that was discussed in Berlin, it has we have two additional numbers. So we discussed in Berlin version 2. We're talking now about version 4. Basically, one of the things that we have done first and foremost has been precisely to align the structure, drafts, and diagrams with the latest agreements on the terminology, and that includes mostly acronyms and definitions all over the document, just precisely to make a consistent use and not redefine things or define things twice. And what is very important is a result on all the discussion on the interface naming. We are keeping the major interfaces that are on the diagram, but there is a discussion on precisely some of the something that at the end we decided to call interface groups. So identifying related set of functions when it comes to particular functions, in particular when it comes to the negotiation between the when publishing information about the functions. There is an issue that I know I was very much strong proponent of the idea of using developer instead of vendor, precisely to accommodate when talking about who is the provider of the function, the entity that is building the function, registering it, announcing capabilities, etc. This is something that I think we still had to discuss a little bit. I prefer the word developer, but apparently there are some misunderstandings that have been caused in the past because of this. Maybe we should try to, well, even I'm moving even to step back, though the word vendor, let me say, is too much associated with a particular way of building the functions and making them available that probably are a little bit outdated in these days of massive use of open source. But anyway, this is something that should be, and that's why I have highlighted it in red. Second is that there is a consensus that was one of the requests coming from Berlin on the attestation requirements and mutual authentication. So we have relaxed a little bit the original requirements. We have formally declared AAA matters out of scope. And still there are some other aspects on the attestation draft that could be incorporated here. Not yet. And this is something that we have to decide before we go for last call. We have made a better alignment of the consideration of the virtualized network functions. So everything is, again, better aligned with the terminology and more consistent. We have addressed several comments received on the list, mostly about consistency of the examples and all the like. Mostly we received it from Gabriel Lopez and others, precisely to clarify the examples and make it more consistent through all the documents. We have updated the text flow. They are much more in accordance because they have been processed using the XML to RFC most recent version. So all references and all the order of the common sections, etc., are aligned with it. And well, according to the usual RFC practices, we have trimmed the list of authors. We have, if I remember well, 9. Now we're at the limit with 5 authors, and people that have made significant contributions are acknowledged inside the text. Next one, please. Finally, well, what comments after is that still there are some parts I mean, some parts from other drafts that could be suitable for being included here in the framework. And this is something that we must align with the WG publication plan. There are some proposals, a proposal made by Adrian about which draft we will progress towards RFC status and which one not. And so the idea is that for those that are not going to be published, probably we could take advantage and incorporate some of the information that is usable as a reference into the framework documents. Second, we had to identify other potential sources in some of the existing drafts, and in particular when it comes to attestation, and some of the proposals around SDN, etc., could be have some room here, at least in the general discussions. And we had this issue of the developer and vendor, and a final is some precise looking at the document and making some assessments, mostly about to see whether we have a well-structured document flow, etc. So it's something that it would be desirable to have some precise reading in detail the documents and making comments as the ones that were made recently, precisely about consistency of examples and all the like. Well, then I think that the document with these changes, that in despite of the length of what is before, those changes I would say they are not really serious. They would not affect the general structure and the backbone of the documents. We will be ready, I think, for working group last call. My only question, and it's something that for the whole group, is whether this framework document shall we stay informational, or we should think about another status. It's something that I'm not to 100 convinced. Probably a framework is basically an informational aspects, but there are some matters that are dealt with inside the document that maybe would benefit from having a strongest status. And that's all from my side. I hope everything went well and you could understand what I was saying. Or seeing me well, or whatever. It's questions or comments.
Thank you very much, Diego. And it's really good. I'm very impressed with the quality. Any questions? If not, then we go to next one. Rakesh.
Okay.
Yeah, it's not this one. IETF. Yeah, that one. Yeah. Hello. Hello, my name is Rakesh Kumar, and I'm going to talk about the working group draft, and these are the contributors which we had in the individual draft. Next slide. So the agenda is, I'll give you just a history of how did this draft come into being a working draft, then the overview of this and the discussions we have and the next steps and plans. So the draft is first we proposed in the last IETF meeting as a draft Kumar I2NSF controller northbound framework. Basically, we listed a lot of requirement from the northbound side or from the client interface side, or right now we are calling them consumer interfaces, how a user would like to see a security policy. Then as per working group chair's suggestion, we changed the draft name to client-facing interface requirement. And then after a bunch of discussion, the working group, we adopted this draft as a IETF working group draft. Next one. So basically the main idea, the scope of the draft is identify requirement to build I2NSF client-facing interface. So if you look at this picture, there's a security controller exposed some interface, and that is the basis of programming a security policy. So the whole idea is we should create this interface so that user does not have to know like what those NSF are, the type of NSF, whether they are virtual, physical, their routers, switches. All user carries from his aspect that, hey, I have these certain endpoints if you see the below the second yellow lines, there could be application, group, server, laptop. You can create groups based on different attribute, define the metadata source, and based on that, you create policy. In the old time, policies are usually created in this, what we call that, the network security functions. User has to know the topology, you just have to know the location where these endpoints are connected, and he has to put the policy over there. So we want to change the framework. So this is the idea behind this draft is, and we want to introduce interface so user can use to program this new way of creating security policies. Next one. So basically, there are few requirements. So we model this after. First is, how do you want to model these interfaces? Like I said, that in the old time, security policy was configured based on somebody understand the network topology, connectivity, the placement of these devices, groups, or whatever your policy enforcement point is. And then somebody understand functionality from a specific vendor, CLI, stuff like that, or management system, then they program. But we want to do it more like a user construct. In the earlier draft, we're calling the user intent, but look like that's a little controversial, so we changed that user intent to the user construct. But the main idea is create interfaces based on the construct user understands. So that is the main theme behind that one. So we broke up these interface requirement into two categories. One's the functional requirement, which user would like to use this. Number one, multi-tenancy, RBAC. I'm going to just scan through very quickly all these things. Authentication, authorization, and then how do we build the security policy? We're going to use the ECM model. Like ECM model could be driven by an admin event, whether you want to program policy based on the, if user decide a policy need to be enforced a certain time of the day or all the time, or based on some event could be from the, like some violation in security or threat level has been raised. Then the second big important piece is a policy endpoint group, which are the actually source and the destination of the traffic, which are the point which participate in the policy enforcement. Then the next big thing is the policy rules. So we want to keep the rules very generic, so you can use these policy rules to build any use case on top. I mean, it could be like a voice over IP VoLTE, which Paul is going to talk about it, or it could be any enterprise network or service provider network. So the idea is behind keep them very simple and generic. Next one. Then the next one is, how do I integrate with any security framework is incomplete if you do not integrate with the external system, because these NSF can only do what they know, but they're not necessarily analytics. They're not necessarily know what's happening is the network or what the behavior is, and they're not really the mechanism to detect the attack behavior or attack source. So the point is you should integrate, provide an interface so that integrate with the external system. Then we want to do the telemetry data collection also through policy interface. So users should be able to program, if they want to collect the data, send it to external system, just like we mentioned earlier, there should be policy associated with that. Then there is a miscellaneous thing like, how do I send event to the user so user can take an action based on certain event, or user can create a policy where the policy enforcement could be automatically driven by the events. Then the second big category, the operational requirement for the interface, like how do I protect my interface from protection from attacks, min configuration, and then how do I make sure my APIs are backward compatible, and how do I make sure all the data model be published, the user can work in a different revisions or different versions, because data model could be, what do you call that, could be changed anytime. Your client may or may not change. So we should have the ability to make sure that client and the security controller can work in a diverse set of environment. Next one. So these are the next steps and plan for the draft is. So this is 0, 0. The 0 1, the plan is add some example, basically. Talking to people, sometimes requirements are not very clear. So I think if we add example for each, so that will make sense what we're trying to say. The next one is we want to expand on the requirement based on the working group contribution, look at problems and use cases and anything else, basically to see whether the kind of interface we provide, whether it can be deployed in a diverse set of environment. Then incorporate ideas from the working group discussion. Few comments have been received, Tiago, Al, Linda, and then we are going to look at them and how to incorporate those ideas. And then we want to solicit input from the on the requirement from the working group member, if there are customers here who would like to tell us whether what we have done, whether it's sufficient or not. Thanks. Any questions?
Any questions? Okay, so this one is just being adopted to working group draft, and we're still soliciting more input. And this is a very important draft. I hope people spend some time reviewing it, because this define the interface can be between overlay network to the underlay network. And with today, with SD-WAN being so popular, so hot, but they don't have any devices to ensure any security policy for their flows. And this define the interface from those overlay from SD-WAN, from others, to get underlaid to enforce the policy. So I hope for people sitting in the room, especially operators, please do review this and see if anything you can add. Okay.
So, Frank, I'm not on notes. So, Rakesh, after our hallway conversation earlier this week, should we be putting the concepts of requirement to be able to express the summary group policy we talked about and the contract group policy? Should this go in the requirements as well as what we're doing in the data model? Because then it'll go requirements, data model. Do you think that's a good idea?
No, that's a good point. So remember, like I said, that what the requirement was, the way we did that was typically requirement what a user or end user or security admin wants to do that. So whether you say it's a policy, it's a contract between two endpoints, let's say you have two endpoint, application group 1, application group 2, and you want to say that this is a specific contract, or you can define the requirement in such a generic fashion that you could say that, hey, I wanted to stop this application group from any external threats. Threats could be CNC, botnet, or whatever threats you have that, right?
Right, and we saw how useful that was at the hackathon when you could use the sort of naming of a group for Paul's work. And I know it's been useful in I2RS to have that naming group. So I really appreciated your comments on having the difference between a contract and the sort of name. That was really useful.
No, that's a good point. As I said, I'm struggling, to be honest with you. Should we keep requirement very generic, where we say user can create any kind of top level interface based on that, or we say contract? I'm open to that. Like if you think, yeah.
And I would hope, Rakesh and I are more on the development side. We'd really, really like some feedback from people who are running networks.
Correct. Actually, what I really want to do is how you guys, security admin, the guy operator, how do you see that? Do you want to create a specific terminology there where the requirement is, let's say, different? Let's say there are two set of requirement. If we cannot generalize that for whatever reason, we should create two different requirement. So requirement, in my opinion, from the operator perspective, what they like a security controller to do. So if you think what Sue said that makes sense, definitely we can do that. Anything else?
Okay, thank you very much. And next is the hackathon. So I just want to add a few comments to the hackathon. I'm very impressed with the work they have done. Paul and his university students, and also he also get other universities, local university students to come to hack I2NSF data model. And the organizer of the hackathon was very impressed with this kind of model. They think this is a picture-perfect way of doing a hackathon. And Yari asked us to write down some blog and so for future way to conduct hackathon.
Okay, thank you very much for your support and interest. First of all, I sincerely appreciate Susan, Linda, and Adrian for their valuable support and advice. Finally, we got the best group work. So I think this is a first step toward the real world of our work. So I2NSF project. So the first question is why do we this project? The first of all, so I2NSF charted to use data-driven approach for the security policy, the enforcement into network security functions. So using netcomp, lastcomp, last API based on open source configuration and protocol. So, so the question is, our approach is enough, or we need to require another security protocol? So in this hackathon, we proved our I2NSF is a good approach for the network security enforcement. So result is we showed the feasibility. Also, network management and operations should expand their work into security. So also our working group also synchronized with other security working groups. And also this open source implemented by the collaboration such as the SKK Sungkyuan University, my team students, also we collaborate with the Korea Telecom researchers, considering reality applications such as VoIP LTE services and firewall. Also the ETRI, the research also joined. So we published this code in GitHub along with the manuals. So in this slide includes that information. So please, visit the GitHub and then the test. Give me a feedback, and then we can going through. Okay. Next slide, please. So this is a post. Okay. So this describes the members, and also this is how to get the code. So in working the development environment and manual. And also our mission was the firewall and the VoIP LTE services. Okay, next slide, please. So the first question is, what are network security functions? Okay, so we already know, right? So the packet and the switch received, and then first of all, we forward the packet to a first network security function according to the policy. Okay, and then if this firewall think this is enough or not enough. In this case, no, not enough. So forwarded to the deep packet inspection, and then in the packet content, it will be inspected. And then if this is a valid packet, forward to the switch, and then finally forwarded to destination host. This is what we are doing in our working group, right? Next slide, please. So our goal is, given the code base for the I2NSF framework, our goal in this hackathon, we implement the firewall for the web filtering service. The second one is the VoIP LTE security services to prevent attackers from misusing the protocol service. Next slide, please. So contribution about this hackathon is, the first one is we showed the proof of concept POC for our I2NSF framework is works. The second one is validity of the I2NSF interfaces design. So client facing and the NSF facing interfaces looks good based on the data models. And also we showed the data model approach is very efficient. Okay, next slide, please. So this slide shows the development environment. So we use the open sources. Next slide, please. So these figures describe the scenario of the network security services. So left-hand side, this is enterprise network with the I2NSF. So we are familiar with this figure, right? I2NSF user and security controller NSF. Also, we introduced a new entity. This is a network security function forwarder, NSF forwarder for the making service chain. And also, we implemented SDN network using Mininet. We emulated the SDN network. So we implemented two services. One is a time-dependent firewall service. So we want to block the work time. Employee cannot access Facebook or the YouTube. Other times they can access. So time-dependent filtering service is implemented this hackathon. And also VoIP LTE service also we prevent, such as some hacker located on Africa tried to connect to some Korean host, and then they tried to make some missed call and then charging a lot of money to the Korea Telecom, for example. So in the past, the Korea Telecom, they charge amount is 20 or 30,000 US dollars, something like that, overnight. So that kind of scenario is implemented. Next slide, please. So the lessons from this hackathon is we prove a concept using open sources. the second one is the validity of I2NSF interface design. So we implemented using this interface, firewall DPI. Also, we showed the feasibility of data-driven security service is very cool. So the young data model for NSF, the consumer-facing interface and the NSF-facing interfaces. So our group, the workflow based on current information models, such as the client-facing information model and NSF-facing information model, we work for this one. Okay, next slide, please. So you can visit this website, and then we recorded the demonstration. So you can see using the MidNet topology SDN network. So we proved our I2NSF is very feasible approach for the data-driven security services. Next slide, please. Yeah. Okay, thank you for your attention and your support. Thank you very much.
Thank you.
Yeah. Are there any questions?
Questions?
Hi, Paul. In your slide, you mentioned that you defined a new component called, I think, the
NSF support, right?
yeah, the network SFF. How is that different from a normal service function forwarder from the service function chaining architecture?
Okay. So basically, NSF forwarder has the more intelligence, which means it interacts with the security controller. So and then try to make a linkage, such as certain security policy, depending on packet source and header. So in that case, the first step is the network or firewall should be scanned. The next step is and the DPI, something like that. That kind of information is stored into the NSF forwarder, and then packet is inspected by NSF firewall, and then this forwarder knows which one is the next DPI. So we're considering the dynamic load traffic balancing. That linkage between the NSF instances are dynamically linked, considering the traffic demands. So actually, this slide will be the last two slides, the draft we propose. Traditional SF-based the service function chain. The other one is just lightweight, our proposal. Actually, two drafts from our group. So Dr. Hyun, he will present the two compare what the difference is, so we can discuss at the end of this session. Okay.
Thanks.
Okay. Thank you. Yeah.
By the way, what's your name? And
Kyle
Kyle.
LaRose from Sandvine.
Thank you.
Okay.
Hi, I'm channeling from Jabba for Dan Ramascanu. He wants to know how many vendors, different code bases, participated in the hackathon.
Okay. So we used CompD for netconf. So and also we're using the Open Daylight, and also we Mininet, the minor systems, and the number of the vendor case, Korea Telecom and other universities such as the Gonggung University in Korea, local university, also the ETRI, the Research Institute in Technology, also involved with this hackathon. Okay, thank you. So the overall, I think more than 20 people participate in this hackathon. They work hard. That's why we got the best group work. That was an honor. Thank you for your support.
Thank you. Thank you very much. Okay, next one is the capability draft.
Hello, everyone. It's Frank Xia from Huawei. I'd like to introduce our capability information model draft. Okay, before I introduce this draft, I want to say that if you can see that it is a 0.0 draft, but actually it's an update from our previous draft. Actually, in the previously we call it a capability interface information model draft, and that is 0.6 version. We have improved a lot on that draft, and then because I2NSF has made some decision on the terminology, and we remove the capability information, capability interface out. So I renamed the draft, and we have some more cursor to contribute more content to the draft. So that's a new draft 0.0 version. Okay, we have the new cursor from the California and the university from Italy. That's current condition. Okay, next.
Frank, wait,
Oh.
it's not plugged in.
Okay, I think this page is very similar in my previous slide, so we can just skip it because this is just just to show that how many interfaces in the I2NSF architecture and what part of work we are doing. Actually, we are doing the NSF facing interface. So how to manage the network security function. So that's part. Okay. What happened to this version? As I have said, we have merged the two related drafts into one. We are very thankful to the other contributors from California and from Italian University. They brought a very good input based on on their experience gained from the Europe Union FP7 secure project. So they have bring a lot of good things, and we incorporated them in our current draft. So which part we incorporate? You can see that in our original capability interface information model draft, we have already defined the basic framework and the detailed network capability information model, and those so on, those very detailed attributes for these capabilities. And by adding their content, we got a more accurate definition for what is capability, and we also use some of their idea from the geometric model to give a complementary content to our current capability information model, such as how to express the policy resolution strategy, how to use the external data, what is the default action. So it makes our information model more comprehensive, more concrete. Okay, and yeah, next. Okay, so that's some changes. Firstly, we remove the capability interfaces and we rename it the NSF facing interface. Okay, and next in this draft, in the working group draft, in the working group terminology draft, it's already provide a definition of what is capability. Actually, capability is a set of features that can are available from the management entity. So so based on this definition, we can have two kinds of capabilities. One is the NSF capabilities and one is the controlled capabilities. But they all can be announced or registered by the registration interface of I2NSF. So the capability is becoming more general for different layer. Okay, and so how to define or how to specify the capability model? So that's a very difficult problem. Currently, we reference some idea from their project. We all know that the capability can be defined by the security capability can be defined by the traffic classification and their related or their corresponding actions. Yeah. So based on this general idea, maybe we all know what is router, we all know what is switch. So based on a lot of summary and analysis, so we try to give give a concept which is called I2NSF, which is generic security functions. For example, you can see we have the packet field, URL field, and so on. So based on these very generic security functions, and we can add them, we can augment or enhance them with some more modulars or extensions. So we use this method to define what the capability that I2NSF can provide to the security controller. So here is an example. For example, we define security capability is IP tables. So it's firstly it's a very generic packet filter. Then if we want this capability to have some stateful control function, so we can add some extension about the set of stateful TCP conditions into this filter, so it can make a more complicated or sophisticated security functions. So it's a very simple example, and here is some set theory to set addition or set subtraction to implement this kind of capability computation. Okay, so we also kept our original defined three basic categories of capabilities, which is network security and content security and attack mitigation. So, but they are just some examples to show how we combine, how we construct the capabilities. Yeah, that's about how we define capabilities and how we construct the more sophisticated capabilities based on the very generic one. Okay, next page. Okay, this page is about, in addition to the definition of capability, we also need to define the very specific security policy rule information model. Okay, so how to define this kind of policy? Originally, we have already constructed a very good framework. We call it ECA model, event, condition, action model, to construct the security policy. But right now we have some more ideas from Aldo, and I think it's very good. It's a very good complementary to our current information model. You can see that in their definition, they can help us to add the resolution function to our ECA model, and also add the external attributes and the default action. So it means that these new attributes or these new classes can be added, can be augmented to our current ECA model to make the policy model more intelligent, more complex, more strong. Okay, for example, resolution function means that if we have several policies, rules, how we design the final action. So, for example, we can use the first match rule. Okay, when we match the first rule, which tell us the action, what is action, or we can use the last match rule, or some priority-based word and other method. So this is a very good complement to our current policy model. And the external attributes means that in addition to the resolution policy, we can also use some external attributes to help us to resolve the policy conflicts or the policy division. So we can use some priority or the creator identity or the creation time. You can consider it as some context information to help us make more fine-grained division. Yeah, and also we specify more detailed condition types, which can be the exact match, the range match, the regex based match, and some customer match. Here, the customer match is more complex. It's the most complex because sometimes you want to define the match condition. Maybe it's very complex. For example, you are the virus, you're a virus scan. So you need to match a lot of content, a lot of characters in a file or in some program. So you don't need to know the detail, the logic in that function. You just define some customer match and like a black box to be used by the security policy. So it's like some customized condition. Okay. Okay, the left several pages, I think there's no big difference from the previous version. Actually, that's about our current basic framework for the security policy. And here we want to say that from actually we use the ECA model that was originally defined and specified in super working group. So that is a very good model, and we inherit and enhance it using on the security area. So we just inherit it. Okay, and this is an example that if we define the ECA model security policy, what is the specific use case, or what is how we use it in specific condition. You can see that we list some example. We can use it for the user control, or for the traffic control, or for some different kinds of security objectives. So we have listed all this content as an appendix in our draft because they are not mandated. They are just some example to show that if we have this basic ECA model, how can we inherit from it and extend it to support different kind of goal. Okay, and next page. Next page is the beginning of our ECA model. This page is about the event. So currently we define several kinds of event: the user event, the device, the system, and the time security event. And they all have their very detailed attributes in our draft. Okay. Next page. And okay, this is a condition. It's obvious we have a lot of condition. We have the security context. We have the packet head, packet payload, and other conditions which can be used to match the flow or the packet and to decide what is the action. Okay, next page. This is action. Action, currently we defined several kinds of actions: ingress action, egress, and apply profile and apply signature. Okay, next page. Okay, next step, we welcome any more comments on this new draft, and we will still need to keep on to make this draft be aligned to the terminology and framework draft to make it more consistent. And then from my understanding, currently we have been more clear about the whole architecture. Currently, we have several work need to do. Actually, I think we have 3 information model need to do. The first is general I2NSF capability information model, because it is not related to the specific interface. It's just how to abstract to express what is security capability and how to register it, how to negotiate. So this is, and this kind of information model can be applied to the network security function side and also on the customer side. So this information is currently what we missed, and I think we need to do more work on this information model. At least in my draft, we already have done some work to describe it, to define it, but not so very detailed. So more work is needed. And for the network security facing interfaces, I think that's the main part of my draft. We've done almost all of this. So, but we, of course, we need more improvement and comments to help us to make it better. But that's my draft work. And for the customer-facing interface policy information, I think it is. We already have our information model draft. So currently, from my understanding, we have these 3 different information model work need to do. Yeah, that's my understanding. And that's all.
Question?
Hi there, Eric Voigt. Question on the ACL model that you have for capabilities. How does that relate, if at all, to the ACL model Yang model being developed. I think it's in the NetMod group.
Oh, yeah. It's a good question. Yeah. Actually, previously, some people has already proposed this question to us. Yeah, I think we should consider this part, the ACL model and the policy-based routing model already defined in other working group. I think in general, there should be some very valuable functions for the security. So how to work together with them, or just reference them, or use them, or to extend them. I think that's a good question. We need more discussion, and we will consider it in the next version.
So Eric, let me be a bit more precise on that, if I may, just add a little color to it. You will have a next presentation about the capability model. And what we did initially was we linked the capability model to for the network policy that actually looks at the ACL. I'm going to have to turn around and face this way. We initially linked it to the I2S packet ECA model that's used by the filter-based RIP. Now that initially had ACL underneath it, that way it belted in, and that's sort of where we're going with it. The other option, so that was our first string. In looking how to implement this very useful, interesting use case in the hackathon, we took a simpler approach. We took the filter-based RIB based on the I2S is fairly complex because it expresses all the things people can do with policy routing in the network right now, and it's fairly complex, and it has a fairly good coverage on all the scanning for particular packets. What we will notice in the current capability model, which I will cover in a minute and show you diagrams, is we actually took a simple model to see if that was implementable and actually had some functional basis. And by looking at the hackathon code with a voice over IP, VoLT, and looking at a service function forwarding, we actually had a test case. So what I'll be bringing up is, should we do a simple, should we do the East complex, should we do an ACL? We need to sort of have a discussion. Now these capability models, if you look at them, could simply say we have policy type simple, policy type extended ACL, policy type packet, but now we're in the place of choosing. What we're actually going to express is the deep level packet dive that you might use for a DPI, you might use for a IPNAT. And so I hope that will provide you context so that when I do the presentation later, you'll know how to plug it into this.
Yeah, just to add to that, that does make sense. When I see the models in the working group, the I2NSF models, I see capabilities which are mirrored in other working groups, the pub sub part, or in the capabilities, where do the capabilities apply? So I see these models so far being very good functional requirements that have to be mapped into the capabilities that are exposed in other working groups, so that we can have the same language and the same structures be used across those different working groups. So if I think about stuff like the capabilities model, even there, I see a replication of some elements that probably don't have to be. It would make life easier if we didn't have to program to multiple APIs for those capabilities.
Yeah, you're right. Yeah, we should include the valuable existing work to make our work not repeat again the same thing. Yeah, we will consider this part. Yeah.
So I think in that process, Eric, we have a bit of implementation, refactoring implementation, because one of the things I'm concerned with is after having done it and starting down the implementation path for the packet ECA, I want to make very clear that we get implementer feedback and figure out what we really need, because not everybody needs the gold-plated policy, but there are people who really use policy routing and use it for DDoS protection, use it for all these VoIPs. So call to the implementer community, and thanks to the guys from the I2NSF hackathon team to giving us our first step. And so that's where I think we're going to iterate at this point. And yes, we really need to stamp out, +1 stamp out duplicates, +1 make the models align.
Thank you very much. Blue sheets, does anybody have it? Can you pass around? Who has the blue sheet? Okay. You raise the hand, meaning you have it. Okay, so next one is the client-facing information model. How do I end this?
Yeah, that's the one. Hello? So this is a draft basically modeled after the requirement draft which I presented earlier. So we follow the RFC 344, which explains what the difference between information model and data model is. Information model could be a plain English text where you could describe all the managed object resources and the relationship among them in order to express a interface or requirement or a language or whatever the context is. Or you can have some kind of modeling tools like UML modeling tools. So I chose the easy path of describing the relationship and the managed resources in a plain English text, and I'll try to go through all of them. But one thing I want to caution that is that this work is still in progress, and a lot of the requirement which we have defined in the requirement draft, not everything has been modeled into or not have been translated into this information model. So this is still work in progress. Okay, next step. So I'll give you an overview, then the discussion, and the next steps and plans. So like I mentioned in the requirement thing, that we divided our things into two things, functional requirement and the basically operational requirement. So I'm going to discuss primarily the functional requirement. So in the information model, like I mentioned earlier, we'll describe all the managed object in order to build a requirement, and I'll describe what the relationship is. I think I summarize them here, but I think it makes sense to read the draft and understand the details. And this, as I said earlier, this draft is based on the requirement draft. So the number one is a multi-tenancy. So multi-tenancy we define like typically in the application world. So let's say you deploy an application in an enterprise network. In an enterprise, usually there is one domain. So this is very similar to what the OpenStack has defined that. And then if you deploy, let's say in a service provider, like a cloud service provider, domain could be represent an enterprise entity, and the tenant could represent an administrative entity within that particular domain or enterprise. Like you could say that, hey, enterprise, you have two different departments that they want to manage their own policies. Then you have basically roles, users, and then authentication methods. So we want to model everything as part of these objects. So user, when they build a policy, they can select any object they want, and we want everything to be basically programmable. And then we describe the endpoint group, which is the main point, like I explained earlier in the requirement draft, where we want to build the policy in a different way, where user does not really care how the network is built and what those policy informants point are there in the network. User really care at the endpoints, user group, device group, or whatever the mechanism is. And we want to make them as metadata driven, because one of the challenge with the policies in the current environment, what I have seen is that even though you define, a lot of vendors let you define the groups, but not they're metadata driven. So let's say for some reason the content of the group changed, somebody have to go and manually update those policies. So this is the main theme around that. Then we have defined the threat prevention object. How do we model threat feed? Threat feed could be, you could have a CNC feed, you could have botnet feed, you could have GeoIP feed, and you can have a basically other different kind of feed where, let's say, blacklist, whitelist, where the enterprise could program that. They want to override, let's say if they got a threat feed from third party and for some reason they want to override that. Then you have malware scan. You want to make it basically very generic, where malware information, how to detect those, that could be taken from the third party, and that information could update periodically. So you want to define object where the content could be dynamically updated. That's the idea behind. Then the event map. So event map described there, you can create a network. In a network, enterprise network, you can create policy based on the threat level. So you could say that, hey, I have 3 different zones or groups in my enterprise network, and the threat level is different in each one. For whatever reason, you have more sensitive data, let's say, in one group, and you want to have a threat level basically higher over there. So you can create the policy and form it dynamic. Let's say if you want to raise the threat of that particular group, if you see some DDoS attacks happening, so a policy can be automatically come to life if they were inactive policies. So that's the idea behind the event map is. Then the next one, like I explained in the requirement draft, we want all the activity which comes from this NSF, whether it's a telemetry or you want to program a policy, that should be done through same interface. So that's why we define this telemetry data, telemetry source, telemetry destination. It gives you a framework where you could say that, hey, I want to collect, let's say, all the flow stats from all the stateful firewalls. So I want to collect all the stats from certain class or category of device. You should be able to express that like any other policy requirement. Then we go into security policy object. At the end of the day, administrator security admin wants to create a policy, and the main building block is how that policy should be enforced. Policy should be enforced, like I mentioned in the requirement draft, based on the user action. Admins say that I want to apply this policy all the time, or he might define a calendar event, or he could define basically, as per ECA model, he can define a specific event that will make the inactive policy active. Then the rules. Rules is the main thing where you define what this policy means actually, what exactly the enforcement point are. So I'll go into detail later on. So next one is operational requirement modeling, like versioning. So these things are probably, there is not to define in the information model itself. Basically, when somebody developing these interfaces, they have to make sure that when they define this schema or when they define this data, whether it's a YANG or whatever the data model you use for implementation, that we define versioning of those resources. So user knows, or the security administrator, which is using the security controller as an interface to program the security policy, he knows what the specific version of the object is. So in case he's using the wrong API, you could find out whether it's not operating with the correct version. I think next one. So in this, so there have been few comments we have received so far, that how do we make sure that our policy rule is aligned with the ECA model. So I think we need to just reword this a little bit, even though the way we have described that follows a similar model, but the language is not correct. So we want all the policy to be defined as per the ECA, and ECA could say that, hey, my event is null in case I want this policy to be applied all the time. Or like I said earlier, policy to be applied based on an event. Event could be time event could be threat events, or could be some other event. And we have to be honest with you, like I said earlier, this work in the progress. We want to make sure, how do we make sure these policy rules are rich and they can translate a lot of requirement, but at the same time, we don't want to do that, let's say you have 10 different features in a specific vendor's implementation. You don't want to create one-to-one mappings. Then the whole idea of abstraction, how the security administrator interact with the security controller, that is lost. So this is the one thing I think I would need some help there. So we have defined a lot of rules which are very common in the industry which we use. But of course, these rules cannot be sufficient for all kind of deployment scenario. So I would really look to operators or security administrator who are in this working group. They help us. Next one. So the next step plan is evolve this brass drift on this requirement. As I was soliciting earlier input, if you think in the requirement document, we have not captured specific thing which people are using there, or maybe our language is not correct. So if we evolve the interface requirement draft, we have to evolve the information model if it is not already taken into account. Then as I said earlier, this was work in the progress. There are more specific idea from other co-author which I have not incorporated yet, and we want to revisit a lot of those things, like the content, what kind of relationship put, to make sure it's very flexible. The third is, like, I hope that we get more ideas from the working group, whether whatever we have done, it makes sense, or whether we need to amend some models or relationship or whatever the comments we have there. And we would like to know also about that, like I said earlier, if there are more requirement, which will translate to information model. So I think those are the things we are looking towards from the working group. I think pretty much, yeah, I don't have anything else.
Thank you very much.
When I, again, this follows through from my earlier comments on the requirements. I think taking the YOU stuff on group policy and factoring into this, it may be that they're two different models, but that if you're factoring them together so you have what you absolutely need, which is the grouping of things, because I need it when I even group stuff in my home as an administrator, and then the group policy. And I think following it through will make this a really good draft.
So definitely, like Sue, I told you earlier, I was looking for Eugene, or like I talked to Frank too earlier. I think let's work on this. Let's see if there is some specific things. But as I said earlier, the information model, I want to keep that, not the implementation details, because the user does not really care, or the administrator does not care how it is implemented, as long as we keep the requirement very specific to, yeah, so that's fine. Yeah.
Hi there, Eric Voigt. I see functional capabilities being exposed to the client interface. Do you have any plans on exposing the current capacity or the current configuration so that people can see or be told that, no, we don't have the capability of doing the interface? Because the way I read it right now is you can tell the network, but it can't talk back on what's possible or not.
No, very good question. So I like Frank said earlier is, as I said, this work is progress. I'm also new to this group. So what we should do, the next thing is, once you capture this requirement, how do you interact with the system? Like you said, the security controller. Either you can just have a one-way street where you ask controller that you have a specific requirement you can meet, and a controller come back to you whether it can do it or not. Or we go to the second things where the client and the controller create some relationship, just like in OpenStack. If you want to know that what all the APIs supported, I mean, that can be done two ways. Either you can create a special interface for that, or you can just request whatever those already you support that.
Just a shameless advertisement. The Yang subscriptions model does allow you to do stuff like that out of the NetConf group. So you might want to consider that to say, here's what I want to subscribe to, and it will tell you if it cannot.
Correct.
Thank you very much. Just a status update. We are 10 minutes behind time, so I hope following presenters can hurry up. Next one is the client-facing interface data model.
May I use the laser?
No, it didn't work.
Work? Good afternoon. My name is Mahdi from SKKU.
Maybe I can put it in your work.
Oh, here. Thank you. Next, please.
Okay.
In this draft, we are trying to define data model for VoIP, voice over LT as a use case based on the I2NSF infrastructure. Introduction, motivation, architecture, and defining the use case for our model, and the next step will represent no. This document tried to describe a data model based on the I2NSF framework based on NFV. We try to define a data model to perform VoIP or voice over LTE security services. As a motivation for our model, we try to defining high-level security, a high-level policy for I2NSF users or client, and we should updating low-level policies based on the NSF feedback or capabilities, monitoring every network's event or behavior to implement security functions, and finally, we defining data model for I2NSF customer-facing interfaces. As you can see, in the I2NSF infrastructure, we have two separated interfaces, customer-facing interfaces, and also NSF-facing interfaces. But all of them, meanwhile, the customer security controller should play meanwhile between the NSF and the clients. Next, please. This is a well-known model, and definitely you know. But I2NSF consists of. Oh, I have. Thank you.
Okay.
Sorry. The three separated layer I2NSF user security management system, and also NSF in the instances make the model of the I2NSF. In the I2NSF users, they're defining high-level security, distributing these policies to the lower layer, and also gathering the feedback to the updating or defining new policy will be done in this layer. Next, please. In the second layer, the security management system, the translating or mapping high-level policy to low-level policy, registering or storing NSF capabilities in the NSF capability manager, and also developer management system try to define or try to mention new NSE capability to register in the capability manager. Next, please. In the lower layer, the NSF instances, the low level policy will be performed at this layer. Next, please. In our model, we consider VoIP or VoLTE as an application logic for the model. In this case, we are defining security. We are defining security condition. We should define the security condition as a blacklist for the IP address of the source or destination for any call in the VoIP, or expiring date for an user's agent, updating any illegal devices manually or automatically, and generating new high-level security based on the feedback from the NSF agents, updating VoLTE databases based on the NSF anonymous detection. Our model is in our model we try to define a data model based on the information model defined by Kumar and his colleagues. In this case, there is a direct connection between our data model and some information model suggested by them as the information model for threat preventing policy endpoint and also policy instances. Next, please. In our model, the high-level policies consist of three main basements. Blacklist countries. For any VoIP calls, we should define the source and destination of calls, so we can define the blacklist or whitelist for this communication, the time interval for a start or end of the communication, and also the caller's priority. Maybe depend the priority of the caller, we can define the several high-level policies based on the normal employee or the manager. We can define different policies. Our data model consists of three units: policy lifecycle management, policy rules, and also policy actions that related to every rule. As you can see, it's a generic model. And next, please. In to define the unit of the data model, in our model, policy lifecycle management define a specific about the time or event experiment. For example, at which time this policy or this rule should be performed. The policy rule represents the specific information related to any high-level policies, for example, service type or conditions. And also action depend to the feedback received from the NSF. We can perform action related to that rule. Next, please. This is the implementation based on the Young model. As you can see in this, in the left side, you can see the policy life cycle or the rules implemented by the Young model. And based on this policy cycle, we define the separated rule based on the conditions. Next, please. For next step, we have to analyze our the Young model in the real cases, in real case of the VoIP condition, and also we try to extend our model to the other use case studies. For example, for untrusted domain or any access control functions. I try to be on time. I don't know.
Yeah, no, that's good. Thank you. Is it your intention that this data model will cover everything that's in Rakesh's information model?
I think we cannot blame that. We can cover everything, but we try to the basic requirement for any VoIP connection. In the VoIP communication, we consider three main basement: the colors, the time, and the action. Maybe your action is can be considered as a malicious activity or the normal connection. So these three, for the first step, we try to cover.
So, my name is Paul Jung, so from the SKKU. So I'm one of the authors. So we plan to collaborate with Rakesh Kumar. So we try to include the genetic model and other services with the Rakesh and the Sujan. So that's all. Yeah.
Okay, good. Thank you.
So next one, is Sue, you presenting the capability Young data model?
And Eric, I will ask you to pay careful attention to some of these parts. Okay. So this data model introduces capabilities. Now, capabilities, just to go back to give Eric some background, because Eric and I have worked together a bit before, is really looking at capabilities. Initial models also tried to link immediately to configuration. This has filters and configurations that were used by the hackathon demo. Again, simple factored model to packet ECA, and then either directly to ACL or to just filters. Okay, this version also had some registering functions, which someone will go on further. There's a long message on the list. I actually, when we were prepping for hackathon on Friday, I actually sat down, took a deep breath, and looked and thought about refactoring. So you're talking to someone who's thinking about it and thought about what we did, what we didn't do, how we're going to test it. Because the real issues about refactoring is a think, implement, check, work on it. The thing we haven't really thought about is how the publication pieces work, because you're actually right. The publication portion of the netconf. Now, we also, in the hackathon, used the ConfD stuff and not the ODL notification, so we couldn't even test it. But this is what we really need to do next, is we really need to think about what we're publicizing, how we're going to publicize it. For example, and this is what we're going, Bob and I have begun to talk to people, and Kathleen, this is where we're going to DOTS and to SET event. This publication function that Eric's been talking about is extremely powerful and can push information. And it looks a lot like what's in the DOTS information, especially what's in the security event stuff, in that it's sending information about capabilities, sending information about events. You might even have telemetry. Okay, next one. I hope that background didn't lose everyone. If I just did, I was trying to catch Eric up thanks to his good question. Please come back and ask me more questions. Now I'll go a little slower and try to go through it. So initially we had everything in one big model. That refactoring makes things hard. So we split it into the team split it into the Kim I2NSF customer-facing model, which we've talked a little bit about the requirements, and registration concept with the model. We also think we need to do this for the client side. You heard me making the comment at the appropriate point in Rakesh's model, in the information model, and in the rest. There is a graph view I2NSF user policy capability that could probably be factored in here. So again, why do we want to do that? We want to make sure we have the user interface covered and then the NSF face covered. And that was one of our learning. Go ahead. Problematic changes, again, what I just said, you know, we went in this case to simple so we could actually get our fingers into an implementation and figure out what to do. Maybe we should go back to draft hairs, and it should be not hairs there. It's I2S packet ECA policy coming from the I2S, which does a complete policy engine that's implemented in most routers or firewall editions. Or should we go to the third choice, which is we get a choice. We give people a choice by factoring it in with a choice in the model. And we need feedback. We're going to need feedback, implementation, and try again. Okay. Go to the next one. Now I'm going to go through the model. I'm sorry, without the background, sometimes just reading you the model gets really dry. And so I'm hoping when I read the model, you can actually then understand. So at the top, we have the capabilities, and we have this security capabilities, and then we go into the actual NSF capabilities. Underneath, sometimes you see the NetSec control capabilities, watch the ConSec control capabilities, the MAC attack mitigation, and IT resources. Now I'm going to pause here because in all of the pre-stuff, I haven't really gone through the IT resources. One feedback we got from Diego and his team that was working on attestations, and they have a research project that actually looks at how one deals with security policies that fight, okay? Because you can define security devices that conflict, and then you might want to have a priority. Well, the good part about working with the NetConf work is that the NetConf work is actually considering this in their data stores in the ops state. But the security work that members of the Telefonica team had done also looked at the higher logic, not just the actual policies and what's in a policy data store, but actually how you might have higher policy to do that. And they published on the list a really good thing, but one thing they needed in the model was sometimes some resource, so that's why that's there. Okay. So let's look at the security control capabilities, and this gets to be a little tiny print, so I'll try to just excerpt it. You note there we're looking, I think we can go to the next slide. This one's a dupe, sorry. So if you look at the NSF capabilities, are we getting the same one and I just blew it? Keep going, the next one. Okay. Go one more back. Maybe something's just not right. Okay, one more back, Linda. I am not getting the slide set in order, I think. Go back to where I started and I'll try to pull it through then. Okay. Okay. Please see the model. I think some of the slides I messed up. But the idea is that we have components at a high level that can register it and actually find the resources. Next. Then we have to look and see high level Yang for network support. And this is the part that I've been discussing with Eric, and it's the overlap between the network portion, where most routers have to have a security policy and have to have it. So the things where we have network support and we have filters, that's what's common with the existing work in the routing area. Okay. And if we get to the antivirus support, that's not really being done in the current NetMod, NetConf, I2S work, but it's good additions. Unless I've missed something. Eric, I don't think we have any, there's no, okay. So that's really good addition. So you can see we have in one case, we're borrowing stuff where we're actually looking at capabilities for filtering for the security devices that might be common between the routing and the security, and we're just using the same models. But when we get to the I2NSF, we're using unique models. Go ahead. And then we have more attack mitigation stuff. Okay. And notice there's first, is it supported, and then a link to every function. And that'll be common all the way through. Okay. And then there's the IT resources, because sometimes you have to know if you can have resources in order to resolve things. Okay. And again, I apologize for the mess up on the actual models. Okay, so that's the way we've taken to work at this. Questions, feedback? Who's overwhelmed by all the Yang model language? And if you're new and we're just throwing that out, please come see us. Okay, other things we've considered. Go ahead, Kathleen.
Instead of just CU, there has just been 2 recent drafts that went through IESG review for NetConf and Yang, laying out the basics.
Yeah,
So,
but oh, don't send them just there for the first step.
really?
Yeah, it's good. It's really good technology, but if they're going to do a first startup,
Maybe I read too many drafts. I thought it was pretty straightforward.
it's pretty straightforward. But leaping from there to this, I would point them there, but with a little help. That was just me being friendly.
Hey, Sue, I've got 2 comments in Jabber from Diego Lopez. The first one was just to note that some of the work you were talking about was worked on together with Politecnico di Torino.
Thank you.
And the second one is, I think what the previous draft proposes would be an ideal test for this capability interface.
The previous draft, meaning the one with the, I'm confused.
Oh, sorry, he's substituted the what and a that. The one on voice over IP.
Yes, that's why it was used for a test on this.
Right.
That was the hackathon test. Okay.
Thank you very much. So next one is the NSF facing data bubble.
Hello, everyone, again. So this draft talking about I2NSF facing the data model. So previously Sujan explained the capability data model. So this is a focus on how to configure the security policy into NSF. Next slide, please. So currently this NSF facing data model is based on the previous version, but we are going to reflect the latest version next hackathon. Next slide, please. So next. So we take advantage from the Sujan, the previous the capability, the data model. So we included more features, such as currently previous one case we just allow just one advanced action, but this revised version case we can allow multiple advanced the security functions such as service chaining. Next slide, please. Also, we included Sujan's more example for content security control, security services, IDS, filter, etc. Next slide, please. Okay. So the previous version case, we just focus on network security control, but based on the Sujan's work, we also included the content security and the attack mitigation security also. Next slide, please. Next. So also we consider we use the grouping feature in Yang to make the more easier view for the audience. And then we support more network security functions. And currently, we just focus on VO, LT, VoIP. So we consider more the service security functions in next the hackathon, and they try to implement. Thank you. Any questions or comments? Okay. Thank you. Yeah.
Thank you very much. So the next one is. the monitoring, right?
Okay, hello everyone. It's Frank Xia, Huawei. This draft is about the monitoring part of the NSF facing interface. So, okay, next page. Firstly, let me give some information about our current discussion in the mailing list. Some questions raised in the mailing list from the original one, very beginning one, is that if this work should be done in I2NSF. Okay, I think most of us think that it's useful and we should done. And the information model is useful for the latest work. Okay, yes. And if our final goal is want to get a data model, so if it is information model very necessary or just be a background material and how to push further. I think that depend on our progress, depend on the final result. So it's not yet decided. And further discussion about the content of the draft. I think nobody dislike it, and somebody said it's a good start and it's natural. It's a very key part of the whole work. Okay, so we also get a lot of improvement content from a lot of experts. So we will consider it and we will improve our draft in next version. So many thanks. And okay, go next part. So okay, so in this version, we do a lot of update, mostly in the introduction part. I list here that the major part that we add to the current draft. Firstly, we add the use cases for this monitoring part. So it mainly describes how we use this monitoring data to do water. For example, we can use the monitoring information to trigger some policy to do some protection, to some mitigation of current attack. And we also can use this monitoring data to guarantee our networks or our devices availability. If we find the system error failure or link error failure, we can use this to we can do something to change it to fix it. And so there are a lot of use cases that we can use this monitoring data. And the second modification that we reorganized, we reclassified our current monitoring data category. You will see later in next page how we categorize them. And we also describe how to expose this information to the security controller. It's mainly related to the exposure frequency and the transport option and a lot of details on how to transport this information to the controller. Yeah, I will give an introduction in later page. Okay, and also we do some minor changes to our basic information model. It means that for all the monitoring data, we all have a shared or general head to represent some basic information. So we do some minor changes to that part. Okay, and next we are according to our new classification. So we restructure our draft section according to the new categorization. And we also update and do some improvement to our monitoring data attributes. Okay, and we have new cursors from Juniper. Okay, and oh, not this page. Should be the previous. Yes, this page. I have already introduced the use case. That's mainly for to describe how to use this monitoring data. I think it's useful for the reader to know their usefulness. And let's talk about the classification. Currently, we have categorized the monitoring data into seven types. They are respectively the system alarms, system events, logs, counters, and the next big category is NSF events, NS logs, and NS counters. So they have different function and meaning. For example, the system alarms represent some failure of the network or the device in their system level, and it usually are very emergency information or event. So for this kind of data, we should use some push mode to send it immediately to the controller. And for the event or logs, they may be not so important or so emergent, so they can be sent periodically. And yeah, they can be more detailed than the alarm. And the counter is some statics of the network event or the policy hit or something. And another big kind is NSF network security function specific. So they are different from the system level. They are the security function level. For example, some IPS has sent some events or logs, or some DPI send they are specific kind of events logs to the controller. So we divided into these two kinds of. And about the way to export this monitoring data to controller, we have covered different points about it. For example, how to use pull or push mode, or use subscriber or publication mode to support the different kinds of data exchange among the device and the controller. So it depends on the on what is the message and what is about the message size, or what kind of the message. Is it emergent or is it not so important? So depend a lot of factors. You can choose different kind of model to send them. And export frequency is also about when and how to send them. And authentication, we talk about something about, of course, among the controller and the device, we need to have some trust among each other, and some basic mechanism is needed here to guarantee it. And about the transport method, it's about sometimes maybe we need a long-lived string for sending our monitoring data. Sometimes it's just a very short message and very quickly sent. So maybe we can use TCP, UDP, core IP, a lot of way depend on specific condition. Currently, we try to list these points to be more comprehensive, but I think some details need to be added to describe them more clearly. I think it will express in our next version. Okay, go to the basic information model. Like I had said, this is about a general head for all the monitoring data. Currently, we list some attributes for them: the message version, the NSF name, and the network security function type and version. So maybe in later there are more general information can be added to this part. Okay, next part, next page. Okay, I don't want to go very detailed in these attributes. You can just have a very quick look of the different category monitoring data we currently defined. For the system alarm, we have a memory alarm, CPU, disk hardware interface. For secure event, we have access violation, configuration change, and the next page. And sys log, system counter. And I list some example very detailed attributes in the right side. And if you are interested, you can read our draft for very details. So you have question? Yeah.
Thank you for letting, Eric, this is where we could really use the factoring case, where a lot of these, Frank, as I mentioned in an email this week, Eric is a great resource. He and the others who have worked on an ODL. The system log, the alarms and everything were base functionality for I2S that was done with the pub sub. So maybe looking at a factoring model where we share common definitions that are common and determine what definitions can either be augmented or whether we have to have separate models. So I think this is a great presentation that will give Eric some data about where he can go. But I think it'd be good to work offline with all of us in a small group.
Yes, I think we can work together to build a general plan for infrastructure for all these security event or monitoring data.
I think that makes sense. The other thing I'd like to have a question on is, do you assume one controller or many controllers for an object? Because if you're assuming one, you don't have to get a readout of what capabilities are on there. But if you have a provisioning system and a security system, you might have to be able to read out in your system what the actual configuration is. So have you, in your function, determined whether you have to see what the configuration is and expose that in a model?
Currently we think it's the controller can be distributed, but for us it's logically one controller. So, and we also consider the capability, negotiation, advertisement. I think Sue's draft is describing about that part. For this part is for this draft, this is mainly for the network security functions monitoring data sending to the controller.
Maybe you've done this, but if there is a place to point out whether it's one controller or logically multiple controllers, that would be good to see, because a lot of people use a different NMS than a security controller.
We can discuss
me.
Later,
Actually, in interest of time, do you mind we discuss this offline?
Okay, I think next page. This is about the NSF specific monitoring data, event, log, and counter. And the next page. Okay, we welcome more comments from a working group, and we will change and align the other document.
Right, thank you. So Linda will sort out the next slides. Just Paul, we've got literally 5 minutes left, and there's sort of 3 slides. So
exactly, Okay. So next. Okay, this is we prove a concept of our draft. Next slide. So next step is this draft already merged by the Sue, the problem statement, and the use cases. So you can give some feedback for Sue's the email, and also we implement so more including more the open sources for reality. That's all. Thank you.
Perfect.
Yep.
You win. Triggered steering. Triggered steering.
Okay, hello everyone. I'm Sang-Won Hyun from Sungkyunkwan University, and this is a brief outline. And actually, this draft describes an architecture of I2NSF framework to provide traffic steering between NSFs. And eventually, such traffic steering enables composite inspection of the suspicious traffic through various types of NSFs, and also can provide some additional benefits like load balancing combined with network function virtualization technique. And our traffic steering is based on the current NSF capability information model. Next one, please. So this is a key motivation of the traffic steering. This figure is about the NSF capability information model. And according to the information model, network security function can trigger advanced security inspection by for instance, content security function or attack mitigation function based on its own security inspection capability. So our main focus in this draft is how to realize this requirement. And to achieve this, we basically need to steer or forward the traffic from one NSF to another type of NSF. Next one, please. So one possible solution is the existing service function chain architecture. So we can achieve the traffic steering requirement in I2NSF framework with this service function chain architecture. So in our previous draft, we integrated SFC architecture into I2NSF framework to achieve the requirement. So, previous slide, please. Yeah, so let me first explain about how SFC works. So basically, first of all, SFC architecture requires predefined service function chain for each type of traffic. So to apply that predefined service function chain to each incoming traffic, it is first required to configure the classifier with predefined chain information. And after that, when each incoming traffic arrives at the classifier, and the classifier performs initial classification based on that predefined chain information. So after that, based on that chain information, this service function forwarder can perform traffic steering to pass through a sequence of NSFs specified in this predefined chain information. So this is about service function chain architecture. Next one, please. Yeah, by the way, for I2NSF framework, it is possible to reduce some overhead incurred in the SFC architecture-enabled traffic steering. So this is the reason why. This picture is again about the NSF capability information model. So important point, the point is, according to this information model, each NSF makes a dynamic decision of the next NSF to forward the traffic. So, due to the reason, the NSF path of each traffic is dynamically constructed, not predetermined. So in I2NSF framework, actually, predefined chain information does not exist. Next one, please. So as a result, we can avoid the burdens due to this predefined chain configuration and management, and the classifier and the initial classification task. So for I2NSF framework, it's possible to achieve traffic steering with more simplified and lightweight architecture. Next one, please. So to achieve our objective, we added two additional components, NSF Operation Manager and NSF Forwarder. So NSF Forwarder takes charge of forwarding the traffic from one NSF to the next NSF. And to do this job, it needs the forwarding information of NSF instances currently running in the system. And that information actually came from this NSF Operation Manager. So based on this forwarding table received from NSF Operation Manager, this NSF forwarder just performs traffic forwarding to next NSF. And another thing is this NSF forwarder is a logical component. So like as in this figure, NSF forwarder can exist as a standalone component, or it can coexist with security controller or NSF. Next one, please. And the next component is NSF Operation Manager, and it basically maintains all the information of NSF instances available in the system. And once requested by NSF forwarder, it provides the forwarding information of the queried NSF instance. Yeah, next one, please. So in summary, the traffic steering in I2NSF framework can be achieved with both SFC architecture and ours. And yeah, so I think this this table summarizes each approach's benefit. So based on this information, we may need some further discussion on these two options. And in the hackathon, we implemented the traffic steering mechanism described in this draft. And as a future work, we will design more detailed information that should be exchanged between NSF forwarder and NSF operation manager, also NSF forwarder and NSF. Yeah. Thank you. Any questions?
Hi, I'm Kyle Rose. Did you consider reclassification at the NSFs as a method to try to choose a different path?
Yeah, to achieve the I2NSF information model with SFC architecture, yeah, we definitely need the reclassification.
So why wasn't that a solution that solved the problem for you with the SFC architecture? Why do we need to define a sort of parallel steering architecture that achieves very similar things but is done in a slightly different way?
But with our customized one, actually we don't have to have classifier component, so we can avoid the reclassification and also initial classification task.
So does this apply? I mean, I guess to me, it seems like the point of SFC was to solve this problem once and for all, solve the problem of moving traffic between different service functions. And if it doesn't serve the purposes of network service functions, did it miss something? Does it need to be updated? Like rather than trying to solve this problem in the network, you know, in this group, maybe it needs to go back to service function chaining and, you know, lead to some changes in that architecture. It's sort of from an outside perspective, it seems like we're repeating a lot of work here. A lot of lessons learned in SFC may not be applied here where they should be, or vice versa. It's just, maybe this is, you know, later discussions or something on the mailing list.
Yes, please do. Kathleen Moriarty. So it's nice to see implementations. And obviously these are still drafts, so we're working out what goes forward. But I just want to give a little plug. I had already spoken with Professor about entering in the code in CodeStand so that we can see what you're implementing in drafts and RFCs. So I'm just going to give that little plug because I do really appreciate the amount of coding that seems to be happening in this group. So it's a positive sign, and you know, making that more visible and other people being able to see your code repositories would be good in an easy to find way.
Thank you.
Thank you.
Hi, this is Kent Leung. I made a couple of comments here. I agree with that comment earlier, right? when you say there's no classification, I kind of wonder that, right? Because even in your first packet that comes in, you're making a classification to decide to go to the first NSF1, right? Because some traffic may not need to even do that. So I kind of question that the ability of just no classification at all, right? So I think there is a kind of classification to decide what service functions need to be applied. And I understand this new thing is that, you know, you don't require a reclassification happening, right? Compared to SFC. But I agree that unless there's a new requirement here, I see what you're trying to do in terms of trying to optimize, right? I mean, the whole point, what you mentioned earlier is that, SFC is static, this is dynamic. I don't quite believe that either, because I think with the SF reclassification in SFC, you can do the same thing, right? And on that, I think there's a benefit of doing it SFC way, because in this, what I see is that you show a very simple case of NSF1, NSF2, and that NSF1 was sent it to 2 after that, right? But what if you have 2 and 3, right? So the SFC framework actually allows you to automatically put it into the next path, right? Which includes more than one. And I'm not sure how this would go, because you would then have to require to plumb in NSF2 was the next hop, right? To even want to change the following paths. So I think we really should work out more details compared to SFC framework. Then I get what you're trying to do. You're trying to optimize, but I think we may not be doing a full kind of coverage. That's my comment.
Let me give you a quick comment. So actually, we have two drafts based on SFC, and you optimized one. So we need to discuss email list. Okay.
Okay. Please do.
Yeah, and that's good. And I would really appreciate it if you could send mail to the SFC working group to tell them about this work so that they can look at it and comment as well. I've just had I had an interesting morning with SFC because I had written a draft somewhere else and talking about SFC and not gone to them. So to protect yourself and also for the good of the IETF, could you just send mail, point them at the draft?
Thank you very much. Okay.
Can you manage the last set of slides in 1 minute?
There's 1 minute. There's one more slide, right? Okay. So that is the, which one is that?
That's registration interface.
Registration. Do I see it? Oh, here it is. The registration interface. Okay.
Yeah, so this draft is about registration interface information model. So as you know, there is a registration interface between security controller and developers management system. And actually this is really important because through that registration interface, we can perform some dynamic lifecycle management of NSF instances, and also can provide some load balancing, something like that. So next one, please. Yeah, so there's a strong motivation for the information model of the registration interface. For instance, dynamic instantiation and load balancing over multiple NSF instances are really important for efficient network resource utilization. So to do this, the security controller should be able to request developers management system to dynamically instantiate a new, dynamically generate a new instance or destruct an existing instance. And another scenario is a certain NSF triggers another NSF, and currently there is no instance of the triggered NSF. We also, the security controller also need to create a new instance. So to cover all these requirements or to perform all these functionalities, there is information model is required for the registration interface. So next one, please. So this is one example, and currently firewall triggers deep packet inspection, and there is no instance of DPI. In that case, security controller requests developers management system to create one instance. And in our draft, this request actually contains some specification of the requested NSF instance, and this we named this with NSF profile. So next one, please. And based on the received NSF profile information, developer management system create a matching instance of the required NSF. And in this case, DPI instance. And developer management system replies to the security controller with the next network access information of this new instance. And eventually, the traffic at firewall can be forwarded to the DPI instance. And next one, please. Yeah, and the next two slides is about another scenario, which is dynamic instantiation for load balancing. So you can easily follow the figures. So the next step page, please. Next one, yeah. So as a future work, we will design more detailed Yang data model for I2NSF registration interface. And we will also implement the dynamic life cycle management stuff based on the current hackathon code. Okay, thank you. Any questions?
Thank you very much.
A quick comment. So restoration interface, even though it's not the milestone yet, but we try to prepare for future demand. Okay.
Yeah.
Thank you. Thank you very much. And thank you for staying extra time for this. Thank you. Okay, then that's the end.
We're done. Thank you.
We're
Yes.
done. Yes. Thank you.